So what improvisation is, and then we should explain the rationale for improvisation in biology teaching. Now, as I said earlier on, as science teachers, we are required to interact with our students, engage our students. Science teaching requires interaction with the environment, materials and equipment, especially biology. As we move on, we'll look at how to achieve that. And I made reference to the curriculum, the new curriculum that emphasizes activity-oriented, child-centered, guided inquiry. So with the new curriculum, it's not teacher-centered. It's not about you pass, pour, and forget. Activity-oriented. And that's the challenge most teachers have. And as a result, teachers are expected to meet periodically, every week actually, to look at how this is being rolled out in the classroom. Most of the time, teachers are tempted, or let me say, they prefer to use the lecture method. The lecture method is not effective as far as teaching science is concerned. So the curriculum emphasizes activity-oriented, child-centered, guided inquiry. But as you perform more activities requires resources. Resources are not in abundance. As a developing country, most of our schools may not have these resources in abundance. Or in some situations, they may not be there. So the challenge is the shortage of materials. And as a result, we rely on verbal exposition, where the teacher talk. Then ask, do you understand? The student also, for in order not to feel left behind, you also say, yes, sir, you chorus response. So why is improvisation needed? Why do we need to improvise? Why do we need to improvise? Verbal exposition limits skill development. That's teachers talking, with student doing, giving little opportunity to actually perform some activity, actually limits skills development, objectivity, and critical thinking. The alternative sources of teaching materials are inevitable. Teachers, students, and community members can collaborate. So, right. Let's look at the definitions for improvisation. Generally, improvisation is basically using alternative resources when real ones are absent or scarce. So that's a general definition. But you have Bomide 1985 and Olagunjo 2000. They look at improvisation as using locally obtained or design materials or equipment as a teacher in your teaching. Then Uche and Umoren 1995, they look at improvisation as making something. Yes, Mercy.
Sir, please, could you please share the slide with us so that we'll be reading along with you?
The slides is you mean you can't see the slides?
No, the screen is the writings here are too small for me.
Okay, I'll do that. And this is all. So I'll send it to you after the lecture. Would that be okay? Because of I
Okay.
don't the WhatsApp on my lesson now. So you after the lecture, then I'll send it to you.
All right, sir. Thank you.
All right. All right. So Uche and Umero in 1995, they look at improvisation, making something unprepared due to sudden need. So we said you improvise you are doing a presentation and suddenly you need to demonstrate something. So that's where Uche and Umere look at improvisation. We create something to explain the concept unprepared. Then improvisation is a teacher-centered and ensures items work as intended. Yes, when it comes to improvisation, you as a teacher, the teacher, you have to actually make that preparation. You, as part of preparing your lesson or planning your lesson, you look at the resources available, and obviously, you the teacher who have to make the necessary inquiries to see whether these resources, all the resources you need, you can get them before you start the lesson. So it's teacher-centered, and you have to ensure the items work as intended. You don't wait till you get to the classroom before you start testing the item, because you are replacing something with something you've created. So you have to test it, make sure that it works as intended before the DD. Rationale for improvisation. The reason, the rationale for improvisation: one, develop problem solving and manipulative skills. Yes. Um, and then we have provide alternative where resources are unavailable. So when you improvise and you come out with materials, students are able to perform certain activities because the real ones are not there, but you that does not prevent you as a teacher from actually coming up with innovative measures to ensure that the students actually get the opportunity to use their hands, and then and so that takes off we'll look at the various domains. So we develop problem solving and manipulative skills, and then provide alternatives where resources are unavailable. Yes, then reduce costs using local materials. Yes, in some situation, if you look at the cost of the material and realize that you can actually come out with something, an alternative, which is cost low, will not cost that much, but you can get the materials easily from the community. Improvisation, it's actually reduce costs using when you use local materials. But as I said, it's not everything that you can actually use local materials to improvise. So then develop creative and technical skills of teachers, students, and craftsmen. Yes, creativity is important as a bio teacher. It's just a matter of you to go to class and teach it, then you go. You have to plan, and as part of the planning, you may encounter some challenges as a bio teacher, and you create you come out with creative solutions to some of these challenges. And so in improvisation, as we move on, realize that it's not only the teacher, even craftsmen within our communities maybe fall upon to develop certain items for our students. Then supplement resources for large student populations. Yes, we'll look at situations where as we go along, I think some of you you are teaching in schools with large class sizes. Is something that's a challenge that we face in this country. So where resources are not enough, but then the system is said that For learning to take place, we are expecting the student to be involved, to be engaged in activities. So through improvisation, you supplement these resources so that other students get the opportunity to also perform various activities. Then conserve foreign exchange by promoting local resource use. Because some of these resources, or let me say, teaching learning resources, may have to be imported. So where you can use our creative ideas to come up with some of them within our locality, it actually conserve foreign exchange in that regard. All right, before we move on to the next session, a quick assessment. As I said, this course will be more we want to make it more interactive because it's an aspect of biology which, or let me say, aspect of teaching that, as you said earlier on, we want to promote student engagement, and so it will not be just the talking will not be done by just one person. You, the teachers on the grounds, you also have to speak, and then we move on. So, a quick assessment here we'll do. So the first one, what do you understand by the term improvisation? Some of you, we heard that some people just log in and then they are just there, quiet. So Kafi is there. Kafi.
Yeah.
Will you take the first one for us quickly?
So let's read the question. So
You can see from your screen.
yes.
Okay. The first question is, what do you understand by the term improvisation?
Improvisation.
Yes.
So
Yes.
it's where you get, you create, or yes, you create something or you design something in place of the original item. Like you want, you are teaching and there is a topic that you need a TLM, but because of the complex nature of the TLM, you have to improve. You can't get the original item, so you have to improvise that particular, I can't say, TLM to aid your teaching.
All right. The next question: explain why there is a need for improvisation in biology teaching. This one, Aaron, Kofi Aaron. Aaron Kofi.
Sir, I'm a visitor.
Pardon?
I'm a visitor.
All right. Abena Meya. Abena. Efua. All right. Arthur Ben Charles. All right. Okay, let's move on.
Hello.
Yes.
Sir, please, you mentioned my name.
Yes. I want you to explain why there is the need for improvisation in biology teaching.
Okay. Improvisation is very important in biology teaching in the sense that biology teaching must not be only teacher-centered, or it must not be, how do you call it, only talking. So the students have to, or the pupils have to manipulate some items to make the class lively, so that they will get proper understanding of the content you are delivering.
All right. Okay.
Hello, sir.
Hello.
Hello, sir.
Yes, we are listening.
First off, let me also.
Okay.
Yeah, most of the biology topics need real objects, and since it is difficult to come by the real objects, there is a need to improvise. So it helps to replace real objects with things that might equalize with the real ones.
Okay. All right, let's move on to the next slide. So when do you improvise? Let's move on. Thank you. When do you improvise? We'll look at that for the session 2. Then objectives we are to state at the end of this session, everyone should be able to state when to improvise in biology teaching. Explain when to improvise in biology teaching.
So we improvise when materials are scarce, the original materials are scarce to come by.
Okay, that's when resources. Okay, provide resources are scarce. Yes, true. All right, let's move on. So, thank you. Let's move on. All right. So, as you rightly said, we improvise when we have scarce resources, materials, and equipment, and then we improvise to substitute with local alternatives. Where resources are scarce, we substitute with local alternatives. We have local alternatives to reduce costs. The resources may be human or non-human. Yes, you may have human resources or non-human resources. You may have a person who has knowledge in a particular skill. Yes, can come and then explain how. Let's take. I think in science, in teaching science, we're talking about indigenous activities in our societies that has biological implications. So we have certain processes like kinky making. Kinky making has a lot of scientific concepts in them, and so you can have a local someone coming to who is into that, coming to explain the steps they go through, and then you as a teacher will identify the sciences at each stage. All right. So human or non-human. Humans, as you said, colleagues, local artisans, community experts, etc., will be classified as human resources. Then we have non-human, which are locally available materials that you can use. Now, the materials or equipment that improvise when equipment is unaffordable, but alternatives can serve the same purpose. Yes, it's very important that in science, whatever you are using to improvise, the original material must serve the purpose. It must achieve the objective. Because it's science, and in science, measurement and accuracy is important. So it may not be 100% accurate as the original one, but at least it should be able to serve the purpose to some extent. Textbooks, despite the fact that in this current new curriculum, the system is moving away from book text to interaction, engagement. So you realize that textbooks have not been given to the students in their hard copies. But then they have learner materials, and these learner materials have been designed in such a way that they have links to videos, tutorials, and simulations, etc., that will enable students to understand basic concepts. So textbooks, however, are used as reference. You need to have as teachers. You don't use only one source of information. You may have books that you use as reference. So currently we don't have physical textbooks, as I said earlier on. Like we have the old curriculum, we have the gas textbooks. The new curriculum, we've not. It's up to subject associations and other um, stakeholders who come out with the textbooks around the new curriculum. And I think that's being done. All right. So with this system, everything is in a soft form. But the learner materials, everything is in a soft form. It's on a portal where the teacher downloads and then use it, and the student also have access to it. All right. So that's a bit about the textbooks. But books are essential for science learning. The fact that we don't have the hard copies doesn't mean textbooks have been ruled out in the new. No, the libraries are there with books. Students can go and then do extended learning even outside the school. When they go on vacation, they can uh, go to libraries and read books on biology and all that. The challenge is that now students of today, they don't like reading a lot. They don't like going to a library to look for textbooks to enhance the understanding. That's how come the focus is now on digital tools, which is students are mostly using digital tools for other purposes. So education is focusing on it. So, but then I believe as we move on, we realize that there are some challenges, though. But then the fact of the matter is that technology has come to stay, and so we have to design our systems around it. All right. So the point there is that textbooks are essential for science teaching and learning, and just despite the fact that the approach has changed slightly, for in the coming into place of the new curriculum. All right, so in some situations, some textbooks are quite high, and so the cost of some textbooks quite high, and but you can't substitute the textbooks. Definitely, it's a textbook, so if once you are using it as a source of reference, student must have access to it. Then we improvise to also encourage creativity. Improvisation encourages creativity, and that it promotes technological transfer through creativity. Yes, and use environmental resources. Promote technological transfer through, as I said, creativity. Use environmental resources and informal learning sites, playgrounds, kitchens, sport fields, markets, hospitals, industries, science centers, zoos, gardens, etc. And that's when students visit some of these places and learn from there. It's actually instill the interest, the learning of science in them. So this informal learning site provide experiences that impact on children's enthusiasm. They get that. So it's not like teaching and learning should always be limited to the classroom. So periodically, students must be taken out. You have biology teachers teaching certain concepts or topics in the classroom when they can easily take the children out for a short field trip or a short visit to a particular site within the school where they can learn as well. All right, so this is then. So like I said, the experiences that the student gain by moving out to some of these places actually boost their enthusiasm and their curiosity. All right, so the next one is Replacing damaged equipment, yes. When there is an urgent need to replace damaged tools for continuity of class activities. Yes, and so biology learning is activity-based learning by doing. So I think initially I said this, that in this modern, the new curriculum, learning is not, teaching is not teacher-centered. You must engage the students. Students must be engaged. They must understand when they are through various activities that you design as a teacher, they understand the concept, then apply the concept in solving problems. So students must be engaged. It's engagement, not you, the teacher. You stand in the class and you talk. No. So biology learning in this new curriculum is activity based, and students must be involved in doing performing a whole lot of activities. But it all depends on how you plan your lesson, which we'll talk about later. Then improvised materials help students develop manipulative skills and construct knowledge. So where damaged equipment are not available for reason being that they are damaged, like maybe you have beakers that you need that are broken down. Beakers are made of glass. You have glass one, now you have plastic one as well. But assuming you have the glass ones and they are broken down, what do you do as a teacher? You have to come out with innovative means of actually replacing this damaged equipment so that students can perform various experiments which requires the use of these damaged equipment. Then we also improvise when there's a lack of materials. Teaching becomes ineffective and boring without materials. Yes. Gone are the days that you go to the classroom, you spend 10 minutes drawing, making a diagram, putting up a diagram on the board. Fine. Depending on what you are teaching, actually, students must be taught how to draw. Okay. But if what you are teaching does not require students to actually make a label diagram of, then you can have other ways of having the diagram available to make your lesson much more effective. Okay, yeah, so teaching becomes ineffective and then boring without materials. So when you have materials, the students will have the opportunity to experiment with. They become more active, they are more engaged, and their teaching becomes more interesting. Then teachers must upgrade knowledge of improvisation. Yes. Improvisation, the fact that we are in a technological era does not mean improvisation must be, it's not relevant. It's very important. It's relevant. Improvisation, because not everything, as we said earlier on, that you may have the real object. So in some situations, you quickly have to come up with your knowledge. Improvisation must come to bear, and then you come out with you display that skills so that your students are always interested in your lesson. Then improvised materials should be safe and environmentally friendly. Yes, the material that you improvise should not harm a student whilst they are using it. All right, so this is the end of this session. So quickly, as we do, we'll quickly look at a few questions, and then we'll move on to the next session. All right, so let me pause and then listen to you briefly, just some 5 minutes. All right, so it's now your turn to talk. David, Joseph, when is the biology teacher required to improvise in biology teaching? David.
Okay, sir.
Davison.
Hello, sir.
When is the biology teacher required to improvise in biology teaching? When is a biology teacher? Biology. You are a biology teacher. When are you required to improvise in biology teaching?
Oh, okay, so the biology teacher is required to improvise when materials are scarce or when materials are difficult to be purchased. So the teacher can use the locally ones.
Okay, that's one. You've given us 2 points. Who else? All right, Alex. Angela Nyako. We have Charles. Ben Charles. Wafo Tando. All right, yes. Angela. Go ahead.
When
Yes.
the real assessment or equipment is unavailable, that is
Mhm.
when the biology teacher improvises.
All right. Then the next. All right, Nash Baba.
When the relia, that's the real material to be used for the teaching and learning, is
Mhm.
expensive to be acquired.
Okay. All right. Is a timing of improvisation necessary in biology teaching? Is a timing of improvisation necessary in biology teaching? In biology teaching, is a timing? Is it necessary that we should? Nash, your hand is up again. Nash.
Sorry, let me lower it. Sorry.
Bright Kwame. Ahama. Bright. Chris Watson. Dankwa. All right. Bright. Aaron Kofi. Aaron Kofi, you have the mic.
Okay. The timing of the improvisation is necessary because when you do not use the improvised material or you do not improvise at the right time, the whole idea of improvising becomes ineffective.
Why? Why does it become ineffective? Explain yourself.
Okay, so supposing at a particular moment you are supposed to engage the student in creativity, meaning you are supposed to improvise and then generate some activity methods so that the children becomes creative, and then you do not use that particular idea at that time, and then you use it at a different time. The concept that they are supposed to get at that particular times do not occur.
Okay. Okay. I think someone
Hello.
wants to. Yes.
Hello. Yes.
Mohammed.
Uh,
Yes.
yes. Timing is important because as a teacher, the time any material, the usage is important. If you have improvised something and you don't use it at the time it is needed, before you realize your purpose will not be achieved. So improvisation must be done either before or during the lesson so that it will carry the learners along. Thank you.
All right. All right. So timing is also important so that you. All right. Perpetua. Kwachi. Perpetua. Honest, Perpetua. Hello. All right. So it's also important for you to also test the item to see whether it will actually be able to perform the work as intended. Okay, you need to test it and make sure that it can work as the original material before you get to the classroom. All right, let's move on to session 3. Consideration for improvisation. Another session, okay.
So please, I have a question.
Yes.
Please, please, does the whole idea of improvisation deals with only material?
Pardon?
Does the whole idea of improvisation deal with only materials? Because it seems that the lesson is geared towards only materials for improvisation.
Materials, equipment that you as a biology teacher but it's not only material. If you look at the definitions that we give, it's not only materials. There will be situations where you may even fall on non-human human resources. Let's say, assuming you are teaching about fermentation. Fermentation is instead of just talking, you can fall on somebody who makes kenke. Is that okay? Somebody who makes kenke to come and take you through the process of kenke making, and in the process you identify fermentation. Is that okay? So it's not only material; it could be human resources. You have a human and non-human. All right. So the session 3. Hello. Hello. Okay.
Please can you hear me?
Samuel Abaka.
Hello, sir. Yes, sir.
Yes.
So, please, I want to, for example, if I'm using technological tool, for example, I'm using something like a projector in delivering my lesson. Now, it has gotten to a practical activity where I have to probably have some equipment and then materials to demonstrate to the students. But it is not available. Now I'm using a computer, I'm using technological tool. Can I download a video to demonstrate to the learners for them to have a feel or to have a view of what I'm teaching? Can it also be termed as improvisation, since it's also part of the teaching that I'm doing?
All right. You are talking about using in some situation using a virtual.
Yes, sir.
Pardon?
Yes, sir.
Okay, virtual lab. What technology gives us the opportunity? What do you call it? Yes, through technology, we now have other technological tools that can also give us an understanding of how certain equipments are used, like as you rightly said, either virtual reality or a virtual reality. We have a VR and then an AR. Okay, yes, but then that one wouldn't give the student hands-on experience. They may see how the thing is used. All right, it also engages them. All right, but then in some situations where there's the student science, you need to measure. You have to take measurement. You need to. So we have situations where you can use that, and then other situations where you have to bring something real on the table for students to actually have a feel. You know, we are looking at the 3 domains: cognitive, affective, and then psychomotor. So when it comes to the motor skills, you need to have something real, physical. All right. So we'll move on to the section 3. We have our objectives here. All right. So considerations for improvisation. So according to BT 1987, for a teacher, before you start improvising, improvisation should not be an impromptu activity as a science teacher. Impromptu. No, it should be well planned, because at the end of the day, whatever you are bringing on board to replace the original material must, because it's science, it must achieve its intended purpose to a certain degree. So we have to examine the content and objectives. Now with the new curriculum, when you come to your what do you call it? Your lesson, your scheme of work, and even your lesson plan. We'll look at it. We have systems in place that helps teachers to actually develop and engaging lesson plan. So through that, as you have to actually examine the lesson content and then the objectives. So you know the objectives, what you have to achieve, and as teachers, you have to state your objectives on the board. The objectives you shouldn't keep your objectives to yourself. Before you start in the student must know your objectives. This lesson, what does it seek to achieve? So the objectives must be clearly stated on the board for students to know. Then identify standard equipment or apparatus needed. You don't wait till last minute when you're about to teach before you go to your head of department to say you need this or you need that. You have to go through the scheme, get familiar with familiarize yourself with the various topics. One thing about science teachers, some science teachers, as a teacher, you must be prepared to learn, especially in this 21st century where technology is now a key aspect of teaching and learning. So you have to go through your topics, go through, now we say strand, substrand, you have to go through your LOs and all the objectives, no objectives. Then you identify the standard equipment apparatus that you need. Is that okay? Then you check equipment store for availability. Check whether the equipment you have that equipment there. You don't wait. As I said, the problem with some biology teachers is that they wait till the day they are going to class. That's when they go and then check whether the item is there. And so when it's not there, you realize that it's actually then affects the whole lesson, because they plan the lesson based on the availability of the equipment. And now that it's not there, they get confused. So it's important that you do this in advance. So you check equipment store for availability of the materials. If the material is unavailable, that's when then you consider improvisation, because the lesson must be delivered. Okay, so you consider how you improvise. What can you do to make the lesson successful? Okay, even if you cannot achieve the objective 100%, okay, as in assuming if you use a real object, the percentage of success that you gain, okay, may not be the same as using the improvised material. In terms of some situations, you may not get the same thing, exact thing. Okay, but at least the students will be engaged. That's the most important aspect. We shouldn't forget that. So use initiative, construct, or substitute with available materials. Yes. So this, as I said, this requires planning. Planning. All right. Improvised equipment. You have some biology equipment and materials, and they are improvised options. Benson burner, yes. Benson burner, we know you need the Benson burner. A lot of schools, when you go basic schools, you won't find a Benson burner. Okay. But the fact that there's no Benson burner, you can get now the kerosene. A lot of people have this portable gas stoves that can be used. Yes, portable gas stoves that can be used. But that one, as I said, as a teacher, you must take control and then ensure that institutions, depending on the age of the children, you put in place certain precautions so that no one gets burned or something. Then, so you come out with a kerosene lamp. Kerosene lamp. In the olden days, when you go, but I don't know whether they still use it. In the rural areas, you have Milo tin, then you punch holes into it, and then you design. You put they even use pieces of cloth, fix it
Are you talking
somewhere.
about Bobo?
Oze, pardon?
Are you talking about Bobo? Bobo
Bobo,
or
yes.
Afraku?
Oh, is it still there in the local communities? Hello?
Yes, sir. It is
Yes.
still here. My grandma has some.
Ah, okay. So that can substitute Benson burner, a Benson burner. Uh, then oil lamp, or even a candle, normal candle. You can use a candle because you're going to heat. You need a source of heat, and so assuming you are to heat something, and you need the Benson base. The textbook is stated as a Benson burner, but you don't have a Benson burner. So what do you do? Then you quickly come out with either a kerosene lamp or stove, or even you can quickly get a candle. All right, then beakers. We use beakers in biology lab. We use beakers because we'll use various reagents and other chemicals, even water. You may need to have water in beakers. Okay, and we don't have beakers. In some situations, maybe probably the beakers you had in your school were the glass one, and glass beakers students easily break them. So depending on the situation you find yourself, you may decide to limit the number of the glassware, and then and come out with other improvise beakers. And how do you improvise a beaker? I think depending on what you are going to use, beakers are not going. You are not going to use it for accurate measurement. Probably you carrying some liquid in it, or let me say maybe you want to see a chemical, whether there will be a change in some activity. Some solutions have been poured in. So the point I'm making is that the beaker, you can have rubber plastic bottles, you cut that and they use it as a beaker to hold some liquid, or tumblers or milk containers can serve as beakers. The measure cylinder. For measure cylinder, since it's going to measure, then you cannot just use anything. But then whatever you're going to use should be able to take some measurement. And so baby feeding bottle. The baby feeding bottle has some graduation on it. That can also be used for measurement. The reagent bottles of cough syrup to contain the various reagents, bottles of cough syrup. Then petri dishes. Biology lab, we use a lot of petri dishes to put our various specimens in them. So if you don't have enough petri dishes, you can use lace of jam jars or jars. If you have a lace of jam jars. And now I said, this is you can't do that at the few minutes, or let me say, yes, that you have to deliver. So if you plan ahead, you can even get it from the student themselves. They will bring these items when you tax them from their homes, and that will make your work easier. Then troughs, you can use plastic bowls, which are quite cheaper to obtain. Hand lens, is a bit tricky here because it's a magnifying glass, and so it's not easy to improvise it. So you need something magnifying or reading glass. Well, that can help to some extent, depending on the type of reading glass you are going to use. So then insert nets, wire frame with mosquito netting or wooden pole. Yes, if you are going to use insert nets, long-handled nets, or even in some situation a quadrats. Going to improvise. You need a quadrat to sample vegetation. You don't have enough. You don't have quad. You can design your own quadrats. You just get the carpenter, and then you give the dimensions. The carpenter with a little amount, you get quadrat design. All right. So these are some of the improvised equipment and examples.
Sir,
Yes.
Please, with
Hello.
regards
Yes.
to the with regards to the measuring cylinder,
Mm,
you made mention of the baby feeding bottle as an improvised equipment, but
yes.
can you also use this mineral bottle, empty bottle, and then maybe create calibrations on a strip of paper and then paste it on the outer wall of the bottle in order to
Mm,
replace the original measuring cylinder? Can that also be
yeah.
done?
It can be done.
Or consider?
It can be done
Okay,
if only you do it properly. If you do it properly.
okay,
Yes. In this situations, you all know accuracy will not be 100%, but at least you still achieve your objective. Is that okay? To some extent, you will still achieve your objective. All right. So
okay, sir.
that can be done. Mm.
Thank you.
Then we come to improvised materials, chemicals, iodine, sugar, salts, locally obtained and preserved in natural water. Then we have animal specimens, um, for animal specimens, fish, frogs, and all that. We all know we can obtain these things from our local environments. Yes, I quite remember I did dissection with my students. But before I grouped them to perform the actual dissection using the rabbits. The rabbit is expensive, so we couldn't get. I realized that the funds available cannot buy rabbits for everybody. Okay, and so I put them into groups, and I asked them to bring frogs. Frogs, yes, and so that they use the frogs to actually start the experiment. So by using the frogs, which were at that time the rainy season, had quite a number of frogs. Everybody had the opportunity to dissect the frog. So so when it got to the time where we had to perform the dissection on the rabbit, it was neatly done. Okay, so that's how improvisation comes in. Okay, so fish, frogs, birds, rats, lizards. At times, students in the course of clearing bushes around their environment may come across. In fact, we don't encourage you to ask students to go and chase these animals because you don't know what might happen to them. But if a student brings some of these lizards and for some reason, maybe it happens, you were there and some student will bring a dead lizard and then you have to preserve it in formalin so that they can use it. But I said, we don't have to ask students to go and look for lizards or rats or whatever because of some of the risk involved in some getting them. But you, the teacher yourself, you can find a way of trapping some of these animals. And then you preserve them in formalin, 10% formalin. I know some are saying that formalin is carcinogenic. I know some are saying that, but we have 10% for 10% formalin is not is you can manage with that, but as I said, the other school of thought that are actually saying that we should eliminate the use of formalin in our labs. Those of you who have used formalin, you still know how strong it is, especially when you take the equipment, the dead animals out of it. But until you have an alternative, you could make do with it. But then you take precautions. You take the organism out of the solution. Make sure you cover it. You make sure that the place is a bit airy before the student come to the lab. Is that okay? So they don't inhale too much of it. All right. But then formalin substitutes. Yes, in some if you are in a village, there's no formalin. What do? Local gin, apetesi. I don't know if you have preserved a dead organism with apathecy before? How many? Can I see anyone who has experience using apathecy as a preservative to preserve some of these organisms that we need in our lessons, that we cannot just throw them away, but we need to preserve them so that we can use them and use them. Some of these, if you go to some of these labs, these animals have been preserved for 10 years, over 5 more years, but they are still intact. How many of you have had the experience of using apathecy? Hello? Is there anyone here who has preserved F1?
No, sir.
Okay. Chris, what?
I use it to preserve snake, snake and lizard.
Snake.
Yes.
For how long?
And years in a glass bottle, airtight.
Okay. Okay. All right.
And fish too, you wash the seawater from it, then you could also use a strong alcohol to preserve it.
Okay.
It wouldn't go bad.
Okay. Okay. All right. So that's the end of this session. So let's look at the assessment questions here. Why do biology teachers examine lesson content before improvisation? Let's interactive. As I said, this time around, your lesson should be interactive. You should engage your students. Don't go to the class and only you are talking. Let's get responses from your students. They also contribute and perform various activities. All right, so who answer the first one for us? Georgina Bedu. Georgina. Helen. Bauni, Isaac. All right. Alex. Clay.
Thank you very much, sir. Yes, sir. I think the biology teacher should examine the lesson content so that he or she can know the materials to go for in making or preparing his resource for the particular lesson.
All right, so biology must examine his lesson so that you know exactly what you need and find out whether it's available. If it's not available, then you come out with improvised. All right, that's good. Then the next, what else? Festus Aqua. Regina Bedu, Ellen, your hand, you came online. Ellen Bowney. Enokopong Yeboah. Emmanuel Yeboah. Joaledu. All right, let's proceed. Yes. So then you also must examine the lesson content before improvisation, so that whenever you improvise, the material you are coming up, you ensure that it actually works before you take it to the classroom. And then outline examples of materials that can be. I think we just. All right, let's move on to session 4, importance of improvisation. We also look at the importance of improvisation in biology teaching. Everybody must be able to do that. Explain the importance of improvisation in biology teaching, and then exhibit the skills derived from improvisation by students. All right, improvisation ensures better understanding of the concept taught. Yes. So we said we are through improvisation, your teaching will not be in abstract. Yes. Your teaching will not be in abstract. You give the student the opportunity to actually use their hands in practical activities, and then promote student interest and participation. Yes, students are much interested in science teachers who plan their lesson And then plan the activities. Make sure that students are engaged. Science is more interesting when students actually practice, they participate. If it's measurement, they perform some measurement. If you said this must be added to this, they add it. If the color will change to this, instead of saying, oh, when you put a few drops of iodine solution on the bread, it will turn blue black. Yes, you have described it, but when the student actually do it and they see the color change, they become excited. It promotes their interest. Okay, so promote student interest and they are actively participating in lesson. Then enhances creativity and resourcefulness. Yes, improvisation enhances creativity. As part of teaching and learning, students can be given various tasks. Okay, to come up with their creative ideas, to come up with certain what do you call it, concepts, if I should put it that way. Okay, yes, they apply their knowledge and then they'll create something out of it and exhibit it. Exhibition. Exhibition, it's not all the time you are just teaching. You can have a day where students also, whatever you've taught, you give them tasks. Okay, it's part of the new curriculum. You know, the assessment modes are not just, we have the 5 assessment modes. One of them is practicals or practicals, portfolio, and all that. So at that point, students can create something and they come and exhibit. Then based on their creativity, you assign them scores and all that. So improvisation enhances creativity and resourcefulness, encourages use of local resources. As over here, as well as the gentleman said, if you are in an area where they brew aperture, which is a local gin, quite strong within certain areas where it is not diluted. In the cities, they dilute it. They add more for, it's not that strong. So you are not careful, it may not be able to preserve the organism properly. But if you are in the local areas where you get strong this local agent, it can help. It can serve as a preservative to preserve some organ where you don't have the formalin. Okay, then brings real life situations into the classroom. Yes, so I said earlier on, um, you are talking about an indigenous activity like bees making, science making, kinky making. You know, when we teach we teach science, biology, as much as possible, we should cite, give examples that are common within the local environment. Okay, so you're talking about fermentation. Fermentation quickly, as I said, cake making quickly. You can fall on someone to come and explain the processes, and you see that the students, the further that person is coming there to, you may even have the person even on campus, within the non-teaching staff, to come in to explain the various stages in whatever and all that. So it brings real life situations in the classroom, and then also reduces costs by minimizing imported resources, and then widen inquiry, curiosity, and application of knowledge. Okay. Hands-on, practical. Yes, as you said earlier on, through improvisation, students get opportunity to use their hands, okay, to perform certain functions and activities, and they enjoy the lesson. So student exhibit skills derived from improvisation. Then tax measure content and the tax measure content and procedural knowledge. And we have activity-oriented learning promotes understanding, as Hartley 1998 said, based on this research. If you have a lesson that is more activity-oriented, it promotes understanding instead of rote memorization. We've moved away from there. We will look at the various dimensions. With memorization, we are moving away. In those times, mentor, yes, 2 by 2, this by that's the old form of learning. This time around, you have to engage the students in hands-on practical activities. Then teachers guide students in using improvised materials. Okay, so in hands-on practicals, you the teacher, you have to guide the students because it's an improvised material. It's not the real thing. So you need to let the student knows the level of accuracy and then how they should go about it so that they can at least obtain the objective of the lesson can be achieved. All right, so the teacher's role is clear. You provide clear instructional objectives, the whole process, as importance of you clear instructional objectives. As I said earlier on, your objectives must be clear. As teachers, we know how you state our objectives. Okay, and so we'll look at some of them. So, in fact, in this new system, planning lessons, we are using technology as a tool, and also through the use of technology, we're able to design more engaging lesson plans. And so teachers have no excuse. And so every teacher designs his own lesson plan. You don't have a group lesson plan, one lesson plan for everybody. No, you design your own lesson plan because you have your students, you know their abilities and all that. So provide clear instructional objectives, create hospitable atmosphere for student ingenuity. So as a teacher, that's your role. You have to provide a clear instructional objectives, then provide material. What do you want to use it for? How should it be used? In order to achieve the objectives, you must give that clear instructional objectives. Then you must create the hospitable atmosphere for student ingenuity. Then support students with instructional materials. Because you are going to impart the knowledge. Okay, so after going through the topics, you have identified the materials that you need. Okay, and therefore you come out with where the materials you don't have enough. You support students with instructional materials. Then ensure safety and meaningful engagement. It's very important. If you are going to use let's say a Benson burner, replacing the Benson burner with this lamp, kerosene lamp. The tendency that students may accidentally spill the kerosene is high, so you have to ensure that it's used safely so that nobody gets burned. All right. So at this point, we look at the assessments for session 4. So let's the importance of improvisation in biology teaching. There's we'll take that for us. The first one. Hello? James Tete. James Tete. Joel Edu. Joel Edu. We also have John Mensah. All right, John Mensah. Okay. Then we have John Sawe. All right, Sarah, okay.
So he said that it brings real life situation into the classroom.
What else?
And then also, it ensures better understanding of the concept that is being taught in the class.
Okay. All right. Then the next one, who's taking the next one? Explain two of the importance listed in question 1. Sarah, you gave us 2, right?
Yes, please.
Yes. Can you take the subsequent question and explain the 2 points you gave us?
Okay. So with the real life situation, suppose there is a, okay, let me frame it like this. Suppose what is being used, or what the teacher wants to use, is a foreign material and there is none available. Through the local one that the teacher has been able to improvise, that students will get a real hand to know the things that was used in making that particular thing, and it will help the students to understand it more.
Okay. The next point.
That is ensuring better understanding of the concept being taught. If a teacher use Realia in the classroom, the students will be able to understand it better than just teaching abstracts. That's how.
All right.
Thank you.
Then okay. The skills. KJC. Then have Kofi Akuwa, Mavis Fosu. Abokafu, she has already spoken. We saw a free here. And a free.
The students develop their psychomotor skills as they manipulate the specimens.
Okay. When you say develop the psychomotor skills, can you give a specific?
That is in the process of using their hands and then other parts of their body to know or get the feeling of what the specimens look like. In doing, they develop these skills, and then also they are able to think critically to solve whatever challenge which is posed before them.
All right. Unless Clay wants to add. Unless
Yes, sir.
Clay.
It also arouses their interest in the lesson.
You are looking at the skills.
Because when they manipulate the, yes, pardon? That is the manipulative skills.
Okay.
Yeah, it arouses their interest in
Yeah,
the
but
lesson.
then, so can you give specific manipulative skills that you think in biology? Let's biology, for instance. Biology.
Okay. That's I think that would be critical thinking, and then result oriented, because when they manipulate materials and then they get a result by themselves, it will encourage them to do more, and they themselves can also go beyond what is being taught in the class on their own to look out for materials and then practice more.
All right. But so in biology, it says why skills, 4 skills students are likely to derive when manipulating improvised material. So when they are manipulating the improvised material, what are some of the skills that they are likely to develop? In biology.
That would be their cognitive skills. Their cognitive skills.
What do you mean by cognitive skills? Can you throw a bit more light on that? Well, they are manipulating.
Oh, okay. It seems I'm deviating small. Let me reorganize myself, sir.
Okay. Nuruddin, Peter. You also have a pump off. All right. In biology, we all know that drawing is very important in biology. Drawing. And some teachers will not teach students their skills in drawing. They only talk. Students don't manipulate anything. But when you give students some specimen, they manipulate, you give them the guidance, and they are to I don't know a day, they have to draw something, a part of based on what you are teaching. So that will enable them to develop that skill, drawing skills. So when it comes to biological drawings, they will not find themselves wanting, they will not shake. And even in using the equipment, I can't remember, there was one boy who was performing. Hello? No, hello? All right. Okay, let's move on to session 5. Limitations of improvisation. And then under that, the main objective is to identify the limitations of using improvised material. So limitations of improvisation. Improvisation, as we all know, is a measure that we take only when we find ourselves in a situation where we need to have an alternative to the real objects, or we need to create a situation for students to have a better understanding of what you are teaching. So improvisations may have a limitation. And so some of them is limited accuracy compared to standard equipment. Obviously, if you are using a feeding bottle to measure a volume of a liquid, the accuracy it may not, the measurement will not be as accurate as using a measuring cylinder. Yes, so then require specific skills to create effective materials. So where you are using as someone suggested, that we use other bottles, and then you have to graduate it yourself. That requires some specific skills to do the graduation. Because if you don't do the graduation properly, the measurement will not be accurate. And they may demand extra preparation time. Yes. To do this, assuming you are going to use plastic bottles, you're going to cut them into half and then use the lower parts as your beaker, serve as a beaker in the classroom. That will demand extra time to prepare. You have to do that days ahead of the lesson. You don't do that the day you are going to deliver. That's when you are going to use the instructional time to do that. No. You do that, you prepare ahead of time. And not always a perfect substitute for actual resources. Yes, it's not always a perfect substitute for having the real thing. So these are the limitations of improvisation. And so under that, we have it's very simple. Limitations of improvisation. We've talked about limited accuracy, requiring specific skills, demand extra time in preparation, and also not always a perfect substitute for actual resources. So this is for the session, the end of the session. So an assessment, what are the main limitations of improvisation? How can teachers address these limitations? All right, so let's move on to the second question, the second part of the question. Because the limitations, we just mentioned them. How can you address as a teacher these limitations? Let me listen to you. Upon Bafo. Upon Paulina Amesaki. Ocharapia. Ruth Amwa. Ruth. You have Ruth Aqua as well. All right, let's continue. Since you're all quiet. Section 6, benefit of improvisation. Benefits.
Sir, please, can you help us with the question 2? How can teachers address?
Yes, you are teachers. Whether you're a teacher or not, this lecture, I assume you're all teachers, because this is prepare teachers for biology teaching. And so the question is, how can teachers address the limitations that we mentioned? So I'm expecting you to give me the feedback, and you are all quiet. No one is talking. Yes. As I said, this course, the way it is, it's to equip you with practical skills. As a teacher, you go to a school and you should be confident in what you do. Okay, so you shouldn't be like only lecture. You have to also make contributions. All right. Who is talking? How can you address it?
Please, with regards to one of the limitations being the demand for extra time in preparation of the improvised materials, can we say that once you know that, let's say you use this material in the next week lesson, you should prepare it earlier before the time for the lesson is up, so that it won't demand much time, or it won't eat into the lesson. As in, you will use the lesson time to prepare your materials.
That's correct, because I intentionally asked you to say so that you because these are some of the challenges some teachers, you go around and the teacher is busy going around looking for something to go and teach, which shouldn't be. You should do that ahead, because it will demand extra time. So in order to as you said, to mitigate against that, you must prepare ahead. Okay, any other?
Okay. Looking at the limited accuracy compared to the standard equipment, when you use an improvised material in place of the standard equipment, you're supposed to give the range of the error. So let's say we don't have a ruler, so you're using a stick. So you should give a range, like let's say plus or minus 10 centimeters or plus or minus 5 centimeters, so that the measurement will be close to the original value that the student is supposed to get.
All right. It's the next one. All right, let's continue then. All right, so section says benefits of improvisation. I think we've stated 4 benefits of improvisation in biology teaching. Exhibit skills gained through improvisation. Benefits. One, we said improvisation provides real life experiences for students. Yes, I gave you examples. Indigenous activities that we have in our grandmothers and grandfathers perform certain activities that has science in them. They don't know that, if they don't know formally that they are using science. But you, the teacher, you identify some of these indigenous activities within your area, and then the science in that, in relation with the topic you are teaching. Okay, and then you take your students there. They will listen, and then whilst they listen, or you invite the resource person, to take you through that indigenous activity. Like, okay, let's take a brewing of apetesi. When you go to most of these local communities, they brew apetesi. Yeah, so the that person who does it comes and then take you through how they go about it. Then you identify the various signs in that, or you go to the place where they do it, and then the student will then see for themselves the various stages where the fermentation takes place, the boiling, where the evaporation takes place, why the how does is the alcohol extracted, what happens, and all that. So they see all that, and then you see that it sticks in their head instead of just memorizing all the stages in the classroom. Theoretically, it gives them the opportunity to have a real life experience as far as the topic is concerned. Then enhance cognitive understanding of biological concepts. Yes, so understanding is made easier where you actually improvise materials, and students get the benefit of actually using their hands. As I said, for instance, you are testing for starch, and it's a very simple experiment. But you see teachers teaching this topic, and they will just be giving the stages. It can be easily done in the lab or in the classroom. If you don't have a lab, you can still perform experiment within the classroom. Just that you have to put the classroom in a certain order. Then you rearrange the decks, and you perform some of these simple experiments, and the students get understanding. So it's not the case that you must get a lab before you can perform simple biological experiments in the classroom for students to gain understanding. Then develop critical thinking abilities. Yes, as students are involved, they use these materials in various activities. They tend to think critically, and that's where uh, 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 um, the new curriculum is geared towards. Okay, students being engaged in activities and bringing out their critical thinking capabilities. Okay, so instead of rote memorization of facts, then instill positive values, such as creativity and resourcefulness. Yes, as you lead you set examples for students. They also follow. It's sort of creates that no. Let me say, you let students know that let me say science is all around us, and it's not just limited to the classroom, and also whatever you do, you are taking the opportunity to create something for them to see how they can use it to in your lessons, various activities. And also it also, if you give them certain tasks to perform, project work, and they are to go and create something, they are willing to do it because you also do it for them to see. So it's instill that positive values such as creativity in them, and they become also resourceful. And then encourages practical problem solving skills. All right, so then we come to the assessment here. Assessment questions. Say for benefit of improvising biology as benefits of improvising biology. Do you need to improvise in biology at all? Or you did once you're a biologist, you expect that everything must be
Hello,
taught.
sir.
Yeah.
Hello, sir.
Yeah. Yes.
I want to
Aqua.
ask this question, please. Yes,
Okay.
sir. I want to ask this question.
Yes.
I want the house to help me with this. The materials given and then they are improvised ones. Did you mention test tube? Did you mention test tube? I want an improvised tape for test tube. Test tube.
Test tubes. All right, then. Is there a question to the floor?
Yes, sir. Yeah. Anyone to help me. Because of the purpose is normally said. At times you can be hitting substance in it. It comes into my when you made mention of for such. So
But in the first place, what function is the test tube playing in the experiment? Experiment. If it's the test, you are using the test tube to hold. Let's say you are. Pardon.
Hello.
If you are using a test tube, let's say you are. Pardon. You are mixing some chemicals, and you in the lab you use a test tube so that when there is a color change, student sees it. And you don't have a test. You don't have test tubes. You can use small bottles, transparent bottles. More transparent.
Okay.
We are not going to do measurements, right? So if you can get some smaller transparent bottles, they can serve as a test tube.
Okay.
I hope is your question answered.
But right. What about where the substances are to be heated?
Pardon?
To be heated. What about in a case where the substance is heated? Yes. And you want to improvise test tube. Okay.
If you have a small transparent bottle, it can be heated. You can heat substances in it.
Okay.
But it's made of glass, so that shouldn't be a problem. All right. Yes, I understand the point where you are coming from. Accuracy here, but then as we said, it's improvised. You are improvising. At least that activity will be performed. Assume you have two test tubes. You have to. You are testing for starch. Okay, and you have the substance. You add water to it. Then you put a few drops of this into it. I mean, you can use a test. You can use you don't have test tubes. You can use small transparent bottles, and so the student will see the color change. Once it's transparent, they will see it. Okay. Yes. All right. What skills are required through the use of improvised materials? What skills? What skills are acquired through the use of improvised materials? And you have to also list two problem-solving skills developed through improvisation. All right, let's move on to Unit 2. We'll finish with Unit 2, Unit 1, and then part of Unit 2. I believe we are meeting 4 times, right? Who's the course rep?
Yes, sir.
Yes, sir.
Yes, sir.
Pardon?
4 times, please.
Hello. So we'll do the Unit 1 and then half of the Unit 2. The next week we'll finish with the 2 and 3, and then the next meeting we'll do part of the 3 and then the 4. I believe we when you do that, we will finish within the time frame given. So let's see. We will be able to finish Unit 2. We'll still call it a day, and then we reserve the rest of. You can use the rest of the time to do your personal studies. All right. Unit 2, Section 1, meaning of profile dimension. So over here, we are looking at the concept of profile dimension. The objectives: explain the concept of profile dimension, define profile dimension, and then apply the knowledge acquired. All right. So concept of proper dimension. As teachers, you know that we have various materials that guides us in preparing for our lessons. One of the materials, or let me say, reference books. Now you don't have it in you have it them in various soft copies. Okay, so reference materials that we use is the syllabus. The syllabus guides us as to what we should teach, how we should go about it, and then assessment. So we have planning, delivering, and then assessment. You plan your lesson, you need materials, you need certain resources to plan your lesson, then delivering in the classroom. How do you deliver? How do you, planning the lesson is one thing, delivering in the classroom is also another. Yes. So as I said, planning a lesson or having a lesson plan is one aspect. Is that okay? And then putting whatever you've planned into action is also another aspect. When I say it's another aspect, you can have a teacher who has a very neat lesson plan, but when it comes to delivery, there's a challenge. Okay, that's how come with the new curriculum we engage teachers every week. Teachers meet. We call it PLC, Professional Learning Community, where teachers meet and we discuss the various approaches that they are supposed to use, because we are coming from an old system where it's teacher-centered. The teacher deliver, and then the students just follow along, and the exams we have chew, pass, pour, and forget, as people used to say. Chew, pass, pour, and forget. In those days, I don't know whether you experience that. Some people put their legs in cold water and say what till daybreak. How many of you did that? Is that a TDB? TDB. Hello.
Yes, TDB, sir.
We are still even doing it. We are still doing it. Pressure from this course. We are still even doing it.
Till daybreak. Are you sure? All right, but at the secondary level, they shouldn't be doing till daybreak. With a new curriculum, they are you the teacher. You are to create engaging lesson. You have to engage them. Now, teaching does not end if learning doesn't take place. If you just teach and learning doesn't take place, you've not achieved your objective. And how would you know that learning has taken place? You need to assess your students. Okay, you need to assess your student after a lesson. You need to the lesson has to be planned well. Planning is very key in having a successful lesson. If you don't plan your lesson, you will realize you'll be somewhere and then the time is up. So, but then when it happens, though, you may have, because you have students of mixed ability. They have some catches the concept earlier. The others also will take some time. So that's that takes us to what we call differentiation. So in all this, you have all this information. You get this information from the syllabus to guide you with your planning. But as I said earlier on, planning a lesson. Now we even have an app. Now AI is part of what we do. in this world. Technology is part of it. You can't do anything. You can't run away from it. Some say, "Oh, you can't say you are rolling back technology and then go back to some years back." No, you have to move forward. Just that we have to find a way of putting in certain regulations so that despite the fact that technology is there to assist, our students will also be guided to think critically. The cutting will be thrown and away. And so in all this, it depends on how you plan your lesson as a teacher. And so the syllabus is very guides you. And as I said earlier on, we have certain tools, AI tools that will help you with your planning your lesson. But instruction in the classroom, implementation is what is the challenge now. Because in all this, in having an engaging lesson will demand more from you, the teacher. Demand more from you in terms of the materials you use. Okay, in some situations the materials may not be available as in its original form, and that's what we talk about. You need to improvise. Okay, if you need biology, for instance, you are talking about fruits and all that. You're going to teach a certain concept. Hello. Yes. Somebody interjected. Sarah. All right. So
Say, Doc,
let's listen
how
to
do
you.
you improvise? How do you improvise um, an experiment such as test for starch uh, in a leaf, or let's say under food test, we are testing samples such as bread, and where you actually need a fresh iodine solution to conduct such an experiment. How do you improvise? Because some of the improvisations, in fact, you can't. If my colleagues will agree with me, you can't. What would be the
You mean a
replacement
typical
of
example?
iodine solution? Yes.
Probiotic and
All right.
How would
eukaryotic
you
cells.
replace iodine solution? So that's my question.
All right. There's also another hand up. Yes. Any hand up? Hey. Yes.
So
Alex.
I also added up. I also added up this topic: prokaryotic and eukaryotic cells. Improvising it at the basic level per se is a topic in Form 2. And when it gets to your time for you to teach, Charlie, you'll be thinking how to improvise it. And normally we go by videos and other stuff.
All right. Yes. We all agree that it's not everything that you can improvise. Okay. I think earlier on we talked about the limitations of improvisation. All right. Any yes. All right. So yes, you have a challenge. But as I said, it's not everything you can. It's not everything that you can improvise. There are certain things that must be bought. That one is clear. Okay. But then when it comes to the solution, you can get the crystals and then prepare the solutions. Iodine crystals, and you prepare the solutions yourself. Okay. So we are not saying that everything should be improvised. That's not what we are saying. Okay.
Hello, sir.
Yes.
Yeah, I
Yes.
want to
also contributes more. I think once we are talking about improvisation, one thing.
Yes, we are here. Listen to you, Gideon.
Human resource, the aspect where man is difficult to.
Oh, Gideon. All right, I think we've lost Gideon. Is Festus. Let's
So I
move on.
said, I guess it's from his network.
Yes. So we'll continue. All right. So we are looking at the. Yes. So the point you are making is it's not everything that you can improvise. It's not everything. But then, as a teacher, what you are saying is that you go through your topics when you prepare your lesson, and then see the ones you can improvise. Okay, before some days before, if there's a need, you are going to teach what do you call it, flower parts, for instance. Flower part, you don't have to, instead of probably drawing the flower parts on the board, you can ask students to go around and then bring some flowers, and then they identify the parts and all. So it's not, I know the when it comes to the equipment, you have a challenge of, well, you need certain skills. But when it comes to materials, there's so many ways you can go about it. You can go about it and using alternative, locally available materials that can still enable you to achieve your objective. So at the end of the day, you want the student to actually have a feel of what you are teaching, the concept, because in this modern time, students don't spend so much time reading text. The students of today, when you give them text, you go and read, especially at the secondary level and then even at the basic level. Text, you see that they when they get home, they spend more time on the screen watching, doing all sort of things. So you have to engage them. You have to give them engage them in activities, and activities in such a way that when students are doing some of these activities, it enhances their understanding. And these activities should be guided. You, the teacher, you structure the activities, and then as you deliver, you also assess to see whether understanding is ongoing before you build upon it. And but the challenge with some teachers is that they continue to teach. Oh, do you understand? Yes. Then they continue. Before you realize simple errors, like when it comes to biology, drawing, it will surprise you. You give a student a simple diagram to a question that they are supposed to draw and label a particular specimen, and they make simple errors in terms of biological drawing errors. Okay, well, these errors could have been corrected if you had given them giving them some work, hands-on activity, and which you then assess, you mark, and then you identify the errors, then they correct it. Okay, so we wait until these errors pile up, then they present it in either mid-semester or end of semester exams. So we are not saying you should improvise everything. A lot of things will have to, but what we are saying is that you should not teach in abstracts. At the end of the day, even if I want one teacher was drawing was teaching the parts of the skin. Okay. In this university, you are spending almost 15 minutes drawing the parts, the skin, and labeling it on the board. That shouldn't be. That shouldn't be. You have to. We have various videos or that you can project, or even pictures you can project, or even at most you can even get a chart. Okay, you bring your chart. If your students are to learn how to draw, then you ask them to in groups. In groups, they draw and come and do a presentation. You give them the specification, what they should, how they should go about it, and they do a presentation neatly, and then you award them some scores for that. So the teaching now, it's not like those days you spend time, you yourself, you draw everything on the board neatly, then you no. This time we are not going that way. So learning involves acquiring knowledge, applying it, and developing skills. You acquire knowledge, you apply the knowledge, and then developing skills. So in the next year, realize that the WASI, how we examine our students is going to change. It's not going to be on the DOK level 1, DOK level, depth of knowledge, level 1, where students will just recall facts here and there. No, this time the focus will be on the level 4. And the nature of level 4, okay, let's move on as we go on the profile dimension, concept of profile dimension, and then we'll look at some of this. So learning involves acquiring knowledge, applying it, and developing skills. Example, treating dirty water through filtering. Yes, so we talk about treatment of dirty water in these scenarios where we have galamsey polluting water. Okay, water bodies. And so it's a topic that has gained a lot of popularity in terms of because of the devastation that is doing to our environment. So when you are teaching a concept of this nature, you have to let them have a picture of what is going on. Probably through a video, you show a short video, they see all that, because you can't take them to a galamsey site. It's very dangerous. So a short video, you download everything, you prepare your video nicely, they see it, and then the engagement starts. You ask them questions. Then they also come. Then you then come in with solutions, or let me say you guide them. So it means that you, the teacher, you must be on top. You must have the control over your content. Content and then pedagogy. The content, knowledge, content, having knowledge on the subject matter is very important, that you go through and then have that on your fingertips. Then you'll be in the position to break it down and then relate it to the problem that is at hand. And then students will then also think critically and then come out with how these problems can be resolved in one way or the other. All right, so the example is a treatment of dirty water through filtering, boiling, and distilling. Dirty water treatment, as an example, the knowledge. A minute. All right. All right. So over here, this is just an example. So over here, the knowledge is what? That the dirty water contains particles and disease-causing organism. Okay. So as well, dirty water. So dirty water means that it contains certain particles and then disease-causing organisms. Then in relating that to dirty water treatment, so that's the knowledge there. Then the understanding, filtering dirty water and examining the sediments. Okay, so you tell them that the water is dirty because it contains it contains what? Particles. like the river bodies polluted with has high turbidity. Turbidity is very high in some of the river bodies, water bodies that you see on television, turning virtually into something else. A very high turbidity. So telling them that the water contains particles, disease causing, that's the knowledge. But for them to understand, you need to bring a sample of dirty water, then they filtering dirty water, and then they examine the sediments. Then they see themselves. Okay, this is the dirty water. After filtering, this is what is left behind. And that shows that this is what has caused the. Then application, choosing the correct treatment method. Yes. How do you treat dirty water? Yeah, so in applying that to even within our polluted water bodies, how are these? We hear the students also listen to news. They also listen. They also hear on us news on television that water bodies have been polluted, and as a result of that, they're not getting. It's cost a lot to treat these water bodies, and that's reducing the volume of water that's being made available to them in their various homes. So how can this be resolved? What then? So that's application. So choosing the correct treatment method, the filtering, boiling, distilling. In the larger context, it may go beyond this. Yes, may go beyond this, especially if you have certain compounds, certain chemicals present in the water body. What can be done to get these compounds out of the water bodies? Then skills, scientific process skills developed through practice. That's as the practice you. So you can have a situation where students even present their work, project work, on how dirty water can be treated. They design various what do you call it, system. Yes, it's part of, I think, one of the competition they attended. It's part it's I've forgotten the theme for it, where students are empowered to come up with systems that can be used to address the pollution, water pollution. Okay, so based on the knowledge they've acquired and the understanding they've gained, they then apply that to develop systems, and then they come and explain it, how the dirty water, the processes it will go through, what it will move, the stages, and at each stage what happens, and eventually how the water will be treated. So that's one. So what's profile dimension? Profile dimension describes analyzing behaviors for teaching, learning, and assessment. Teaching, learning, assessment. Okay. Most of the time, teachers assume that once you teach, learning has taken place. Once you go to class and you teach, you can have a teacher going to class, spending 1 hour teaching, and another teacher going to class, spending 30 minutes teaching. And when you assess the same students, you realize that the one who spent even 30 minutes, after assessing the students, the feedback you get shows that learning took place. Okay, compared to even the person who spent 1 hour. What I'm trying to say is that you can spend 1 hour teaching without actually achieving, without learning actually taking place. The fact that you are teaching doesn't mean learning has taken place. Okay, because probably you are not adopting the right pedagogies. Talk, and the students, they're also looking at you. Probably you are not even creating the atmosphere for them to ask questions, and so eventually When you are done, you ask, do you understand? They all give you the positive response and you move on. But actually, when you break down concepts, you use the right pedagogies, you engage the learners, okay, and then you assess. You come out with assessment that shouldn't be a lengthy one, depending on the topic. You just want to achieve a certain objective, so you set questions, and the questions, as I said, this time around, the questions should not be just recall. It should be application. Okay, and then so you assess. When you assess, then you get to know the students who have actually understood your lesson, those who are lagging behind, and those who are in between. Then you know how to structure your lesson the next time you come in. Those who have understood should not be pulled back. But then those who are lagging behind should also be not. You don't have to leave them behind. So that's where the differentiation comes in. So as a teacher, you put in certain method, what do you call it? You adopt certain pedagogies, and in this case, as we said earlier on, more practical hands-on experiences, and then you see that your teaching goes on. So teaching activity designed to facilitate learning by Smith 2007, as you said, I said earlier on. Then learning is acquisition of knowledge, attitudes, skills, and capabilities by Farrant 1990. So you are the teacher. So you design activities to facilitate learning. As to whether the knowledge has been acquired, attitude, skills, capability have been acquired, that's also another. So that's where regular assessment comes in. Then assessment identify the gaps between teaching and learning. Then you provide remedies. So we need to structure our teaching if we are to achieve our objectives. So teaching, learning, and assessment. Teaching, learning, and assessment. Shouldn't sacrifice any of them. So teaching and learning are interrelated activities, binding teacher and students. As you know, you're teaching, you teach your students, then you engage them, you give them practical tasks, practical activities, hands-on activities, you give them extended. Even now, as you said, I told you earlier on, learning is not limited to the classroom. So you shouldn't be like, we will not be able to cover the syllabus. You have to sit down, look at the topics, identify the ones that you can give to students. When they go home or during the weekend, they can also do some research work. Now collaboration is key. 21st century skill, collaboration. Yes, collaboration. They come together. That's how come we are giving them digital devices. Although some are abusing the use of digital devices. Okay, but then the digital devices are now become an integral part of teaching and learning. So saying that you not give it to them to do so, because at the end of the day, parents provide these things for them, and they are data natives. It's also enhanced their, there are so many means through which they can also learn certain get information using these digital devices. As you said earlier on, at times we focus too much on the negative aspects, but then we also have to guide the students, to be good digital citizens in terms of how to use the digital devices for its intended purposes. All right, so teaching and learning are interrelated activities, binding teacher and student, as I said earlier on. Assessment ensures alignment between what is taught and what is learned. So until you assess your students, we have different types of assessments. Okay, you have the assessment for assessor us, and then assessment of learning. We have the diagnostic assessment where if you are giving a class for the first time, you don't know where they are, their level. You have to come up with a diagnostic assessment. So based on the feedback you get, you know where they have reached, in terms of the understanding, and then that will also inform you as to how you also take off. Okay, so it shouldn't be like, oh, you are giving a class from Form 1, you have to teach it up to Form 3. No, you should. That's what some. I'm not the one who started. Fine, but they've been given to you. You should be able to assess them and know their strengths and weaknesses, and then develop the various remedies to help them catch up where they are lagging behind, and then you move forward. So proper assessment helps teachers address gaps. That's the whole thing. If you assess, you plan your assessment, and don't forget that I said it now. Going forward, assessment of students will not be on the on only the DOK level 1 and 2. The focus is now moving on to DOK level 4. The DOK level 4 involves more critical thinking, because over there students are to apply. You give them scenarios, and out of the scenario, they are to then come up with the solutions. So that's how the way we are going in terms of even with WASI and all that. All right, so assessment here, what's meant by the term profile dimension, distinguish between teaching and learning. By filtering, boiling, and distilling dirty water, the student acquires what does the student acquire? Then you define assessment. Let's move on to slide 2, unit 2, section 2, the 4 learning behaviors. So on this slide, you have to identify the 4 learning behaviors, explain the 4 learning behaviors, and describe a type of behavior. Describe a type of behavior portrayed after completing a task. All right. So this session builds on session 1, profile dimension, learning assessment, and we focus on the 4 learning behaviors as dimensions of knowledge. The 4 learning behaviors as dimensions of knowledge. The 4 learning behaviors, you have knowledge, recall facts, describe, state. Okay. Then we have understanding, explain, summarize, give examples. Application, use knowledge in new contexts, solve problems. Then process, develop, plan, construct. These are words that are used in various assessment that covers the 4 learning. So in our assessment, we make sure our test items covers all these 4 learning behaviors. Action verbs and objectives. Yes, in stating our objectives or learning outcomes, each syllabus objective contains an action verb. The verb indicates the behavior students should demonstrate. Okay, so by the end of the lesson, students should be able to explain, describe knowledge, explain understanding, construct application. So if you give an example, you set your objective. By the end of the lesson, students should be able to describe the process of digestion. Able to describe process of digestion. That's knowledge. Okay. Then explain what happens if a student ate banku and fish. Explain what will happen to the banku. Explain what happens to the food, such as banku and fish, when eaten by students. What will happen to it? Is that okay? So that one, understanding. Yes, you giving the student a scenario, banku and fish, or a student ate gari and beans of plantain. You have to explain what will happen to the food. Okay, yes. So then construct. when they have to construct, that's where the application comes in or process. All right. Importance of higher level behaviors. Traditional teaching, as we know, traditional teaching stresses on rote learning, roots, 2 by 2 by 4 by. I'm not as experienced as when we were young. Our teachers give a mentor. You know they call it mentor, right? Hello. Hey. So the
Yes, sir.
Yes, sir.
mentor.
Mental.
What was it good? Yes, mentor. Was it good?
Oh, sir, in a
It
way,
was good,
it was tough, you know.
Pardon?
It was good.
Don't forget, it goes with training.
It was good.
It goes with training. You know that. Pardon?
Say,
Uh-huh.
my father, for instance, now in our days, simple calculations, we go for calculator. Simple calculations, calculator. My father, for instance, during his time, and even up to now, there are certain big in the figures, Charlie, and he always attributes it to the kind of training that they got in their days. So, in one way or the other, the advantage and disadvantage in everything. So I would say that in some parts, it made the student look sharp. Not forgetting that too much caning is too, or maybe the way we administer the caning, that's the problem. But these mentors and other stuff, it helps. It helps a lot. It makes the students stay sharp.
It keeps them on
I
their
do know that
toes all the
some
time.
students hate mathematics because of it.
Yes,
You
sir.
know that some
This
students
this
hate
mental
mathematics.
thing has made some of us hate mathematics and even our math teachers. So for me, I don't believe in that
Proper one,
mental
mental,
thing.
proper one. Yes, sir.
And don't forget, our fathers, they were being trained to sit in these various shops and
Mental.
in those times, GMPC. Take care of at that time, technology too wasn't so advanced, and we were not having as it's not easy to have a calculator at that time. Okay, yes, and we are in an era where you are not limited in terms of information. Okay, an era where tertiary education equips you to be able to solve problems. So wherever you find yourself, if you are asked whether you can solve a problem, you don't limit yourself to say no, because you are ready to accept the challenge, because you know there are resources that can help you. Is that okay? Yes. In this modern time, becoming you can imagine becoming a doctor in the olden times and becoming a doctor now. Now doctors are using technology to help them with diagnosis. Is that okay? Yes. In even in medical school, before you perform, you learn how to perform surgery and other things. You have seen simulations that will, even some of us, we watch some of these things on social media, simulations on how. Just a minute. All right. Yes. We get information as to how certain complex medical procedures take place. So those simulated videos and all that. So the era we find ourselves, if we if we use the old form of teaching in this to teach this current crop of students, it's going to affect the kind of manpower that we will generate. Because in this modern times, we need uh, um, students who have been trained to use to be able to um, what do you call it? Solve problems. Is that okay? Yes, the education is geared towards training students on how to identify problems and how to solve these problems instead of just learning about the problems. All right, so traditional teaching stresses on rote learning, as we said earlier on. Memorization, chew, pass, spoil, and forget. Last time you heard the former minister, talking about the, now they are piloting the new curriculum, and you hear what he said. The focus will be on the level 4 scenario, but the scenario-based questions are a bit tricky. When I say tricky, as a teacher, you must also learn how to frame scenario-based questions. You must learn how to frame them. Is that okay? If you don't frame the scenario-based question properly, you confuse the students. And when they get confused, they also confuse you. When they get confused, they also confuse, but they'll be throwing questions at you. And you're not careful, you also be confused. So you have to take your time and make sure you frame your scenario-based questions well, and then you guide students as to exactly how to answer them. Some students answer scenario-based questions by talking about the scenario. Even in tertiary institutions, like some of you students, when we give you scenario-based question, you realize that the student is just talking about the scenario. The scenario is already in the question. Yes. Hello. Let me.
So please, I just want to add to what you are saying concerning certain questions using scenarios. Now you see they are already doing that with the basic school, that is the BEC.
Yeah.
For some time now, if you take a look at the RMU questions, they've been using scenarios, expecting that the children will be critical thinkers and then be able to come out with the answers. And so we, the teachers that are teaching them, we have to start practicing these things, asking or setting their questions using these same scenarios, so that when they get to the BEC centers, they won't suffer. But now we are not doing it. And so the moment they get to the centers and then they see questions in the scenario form, then they start complaining that it's difficult because we didn't start with them.
It's true. You're right. Just like last year, 2025, social studies, because of the scenario, all right, so Yahaya Abdullah.
The point I wanted to raise, yes, sir. It looks as if the point I wanted to raise, you just started at this and bringing it up.
All right.
So yeah.
All right. So let's continue then. All right. So new approach emphasizes application, analytical thinking, creativity, and problem solving. So as teachers, we must make sure we also master these skills. We must, because you are you're going to impact the knowledge. So if you yourself you are lacking, then how do you go about it? See, so it means that as teachers we must be ready to learn. We're ready to learn. But in most cases, teachers find themselves in situations where they themselves do not prepare. So, okay, it's you need to learn. You must. We say you are a learner. I'm a learner. We are all learners. We are in an era where technology is advancing. A lot of things are coming up and all that, and so we must also adapt, and then come up with instead of staying in our comfort zone. Some teachers are still within their comfort zone. They want to remain. They want to still go about the teacher center. They go to the class. They are the ones only talking. So that's a challenge. But now that you are here, all right. The content column, the syllabus provides selected core ideas for each objective. So as you go to the syllabus, now as I said earlier on this syllabus, they are available. You download them in their soft form. Then you go through. Some teachers don't even take their time to even go to the syllabus. In fact, when you read this, there's a lot of information you can get from the syllabus. A lot of information that will enable you to plan your lesson and then achieve your stated objectives. Sometimes it's exhaustive, but sometimes require teacher to add more. Yes, in some situations, whatever is stated in the syllabus may not be enough. You need to read further for you to also gain certain mastery, so that when you get to the classroom, you, as a biology teacher, you will not, if a student poses a question to you, you will be in a position to answer them. So what are the four learning behaviors exhibited by biology students? Why does each specific objective contain an action verb? And then how is the content in third column of the syllabus important in biology teaching? All right, any responses from you? If you don't make a response, I'll move on to the next slide. All right, then move on to Unit 2, Session 3. So we'll end of Unit 2, Session 3. So the next week we'll go to Unit 3 and then finish off the Unit. We'll finish with the Unit 2 and then the Unit 3. And then the next one will be Unit 4, and then part of 5, and then the final one will be the end of 5 and 6. All right. So end of Session 3. Teaching and learning activities. Identify activities that ensure maximum student participation. There's the objectives. You have to identify activities that ensure maximum student as a teacher. Then avoid rote learning and the memorization. Explain the domains of knowledge. All right. Let's teaching and learning activities. Yes. As I said earlier on, planning your lesson is one thing, and then using the appropriate pedagogies to deliver is also another. You can have a nice lesson plan, okay, but when you get to the classroom and you don't adopt the necessary, you don't implement it fully. In some situations, teachers plan their life. If you go to the, but now we have apps that are making the planning of lesson easier. You have to provide the necessary information, and then the app generate a lesson plan for you. But that's one thing. You having a neatly prepared lesson plan, but then implementation, that's the challenge you're having now in most schools. Teachers, as the lady just said, teachers we don't take our time to frame test items that involve DOK level 4. But framing scenario-based questions, you need to sit. In fact, in this modern times, framing scenario-based questions shouldn't be difficult for you as a teacher, unless you don't know how to use technology. And now technology is part of teaching and learning. It's part of it. You can't take it out. Okay, you can't take it out. So every teacher is required to have a laptop. If a teacher don't have a laptop, then you are lagging behind. Though. I believe everybody here has a laptop. Hello? Hello?
Sir.
Yeah, please.
Sir.
Everybody has a
Yes.
laptop, right? Yeah.
They are giving them to
Sir.
Masusa. They all have it.
Because if you go for an interview, you don't have a laptop. That's the first way. If you don't have one, you will not be given an assurance letter. If you don't have a laptop, you will not. Because some teachers are waiting for the government to come and give them money to go. You don't need to wait for government to give you money before you get a laptop. It's a tool. You need it. So how you get it is up to you. You have to come out with ways of just like you have to raise money to go and buy something else. You have to come out with ways, a means of getting squeezing some money to get one. So teaching and learning activities encourage participatory methods. Now, when you develop your lesson plan using these apps that have been designed, you realize that the activities are all participatory. You have various methods that you use that the students will be engaged in various activities that will enable them to grasp the concepts instead of mathematics teachers. I don't know. Maths teachers, they always one of the group of teachers who are always kicking against the use of technology. Mathematics teachers, they always want to adopt the teacher centers, but there are a number of activities that you can use to also let students enjoy mathematics instead of always you go to the board and solve. I know when it comes to mathematics, having the necessary activities will demand some time of yours as a teacher in order to have a better activity that will enable students to understand what you are doing. So encourage participatory methods, teaching and learning activities, encourage participatory methods, avoid drill, encourage participatory methods as a teacher, avoid drill-oriented approaches. Drill-oriented approaches, that's what we talk about. Drill. That's we call it mental drill. Then emphasize cognitive, affective, and psychomotor domains. That is what we talk. Cognitive domain is the affective, cognitive, then affective, and then psychomotor domains where they have to use their hands on. All right, so practical problem-solving approach. Practical problem-solving approach begins lessons with a practical problem. Yes. If you want students to actually develop their ability to solve problems, you must also, in your lesson, identify some problems related to the lesson. If it's biology, you must identify problems within the community, not problems with somewhere in US or UK or wherever, where it will be too abstract. Within their community, you can have some problems there that can be related to the topic, and then you can then develop their critical thinking abilities through the various pedagogies that you use. Okay, then use prior knowledge and external information. Student prior knowledge, as you said earlier on, students come from communities and they have they don't come with an empty head. Okay, they don't come with an empty head. They've learned a lot of things within their community already. So you have to structure the learning process, formal learning. So you have to identify the prior knowledge and then external information that you use, and that will enable you to develop practical problem-solving approach. Then analyze, suggest. When it comes to analyze, use words like analyze, suggest, criticize, justify, and evaluate solutions. Okay. Purpose of teaching and learning. Because it helps students apply knowledge in and out of school. Yes. Knowledge gained is not just for the school. So when they go, they throw their books away and then they go back to square one. No. Whatever. That's why, some students, whatever you teach them, when they go home, and even their parents try to sort of give another version of whatever has been taught. Some of them will sort of challenge their parents. That's not what their teacher taught them. So in that case, in science, biology, you have to make sure that whatever you are giving to the students is accurate. If where you have a challenge, you will find a way of way about it. So help students apply knowledge in and out of school. Then develop analytical thinking and problem-solving capacity. That's the purpose of teaching and learning. So in this current curriculum, analytical thinking and problem-solving capacity is yes. The focus is on that aspect instead of recall, stating your facts. Okay, because now you can easily get facts from your using a smartphone. You can just get stated facts. Okay, yes, it's really available, and these devices are always with us. Okay, but then applying the concepts, the knowledge gained, that one in particular is certain in problems within our communities. So you can set a question, a scenario-based question, and the problem that is to be resolved reside within a particular community. Okay, so if that question is given to somebody elsewhere, the person may find it difficult to even go about it, because depending on the nature of the problem, though. So, purpose of teaching and learning, as I said earlier on, develop analytical thinking and problem-solving capacity. Suggestions and exercises, oral questions, quizzes, assignment, essays, project work. In the new curriculum, the assessment, we have 5 modes of assessment. We have the class exercises, the ones you give the class exercises, and then we have assessment policies. Yes, assessment policies. You can have an assessment policy can vary. Maybe your school, you can decide, depend on the class size. I don't know, depending on class size, you may decide, okay, at the end of every week, for you as a teacher teaching biology, you must give maybe one exercise and then mark an assessment policy. Okay, so it means that by the 4th week you have 4 exercises, out of which you can choose one and then record it for the students. Continuous assessment as a formative assessment. Now, formative assessment is carrying 60 marks. Formative, and then the summative, as you know, end of semester exams was carrying 40. But then the class exercises, mid-semester exams, practical or portfolio, group work, practical work for biology, practical work, and then the group work you give them. At first, we're having individual and then group. Okay, so group work, and then the last one is end of semester exams. So these are practical 5 assessment modes, and so all of them has their weight. 1 to 4 will carry 60 marks, and then the end of semester exam will carry 40. So if a student doesn't come to school for all this while and write an end of semester exam, the student will fail. Is that okay? And the same way, if a student has come to school regularly and for some reason is not able to do well in end of semester exams, he also gets a good grade to progress. Okay, so it's like the emphasis is not only on the summative, that if the student doesn't do well in the end of then that's it spells doom for that person. Right, so oral quizzes, assignment, essays, project work. Project work, when you give project work, you are tempted to give one. I'm talking about the what do you call it? The guide as to how you mark your project work. You assess the student. You're not careful, you'll be tempted to. It's a group project. There's a probability that some students may not take part. They are just there by name, but they didn't contribute. So that's where you must actually find a way of making sure that every student participated in order to give them scores. So you don't give one score, 15 for everybody. Everybody in the group gets 15 marks. No. Or everybody gets 10 marks. No. Depending on how the the questions you pose to them, and then the responses you get, you know that you know those who actually did well, and then you have a real criteria. The criteria must be clear to the student. You don't have to ambush students this time around. Let them know how you are going to assess them. How you are going to assess them. They have to know how much they are getting. Group work. It's a group project, but everybody must know. Okay, you had this. It's on the board. Either you project it or you write it on the board for them to see, and then you must take record of it. Then creative evaluation task to test mastery of objectives. Okay. All right. Importance of lesson plans. Yes, lesson plans. Its importance. We can't. Lesson plans are very important in lesson delivery. Yes, and the syllabus is not a substitute for lesson plans. Lesson nowadays, as I said earlier on, you have no excuse as a teacher not to develop your lesson plan, because now you have tools that will assist you. Just that the tools will also, it doesn't mean that the tools will automatically generate your lesson plan. You have to make necessary input. So it means that you have to understand the demand, the nature of teaching and learning in the new curriculum. You have to understand the various concepts. When say differentiation, for instance, what does it mean? Differentiation. You should know what differentiation means. So it means that you have to be learning. Think per se. What I mean, you must understand all these terms. Then the system will generate a lesson plan for you so that you can implement it. That's the delivery aspect. You can do that effectively. So teachers must develop schemes of work, a detailed lesson plan. Now, schemes of work, the system has it. You have all the scheme for the year, 2 semesters. Everything is there. You are following. There is a standard-based curriculum. Standard-based. It's not the previous one. The standard-based. So what we are teaching here this week, they've standardized everything. So week 1, 2, 3, 4, you are doing this. Week 5, 6, you are doing that. From this week, so everything has been standardized. So that's how come we have various pedagogies that you can adopt to make sure that you are meeting the targets. Okay. Because if you should adopt the previous method, teacher-centered approach, you will not be able to meet your targets. You will not. Because the students wouldn't get what you teach. They wouldn't understand it, and they won't be able to apply the knowledge. Okay, gained. So end here with the last assessment or session 3. What are the domains of knowledge? How will you help students acquire analytical thinking and problem-solving skills? State 4 forms of evaluation. So this one, I'll listen to you. Then the rest of you use the rest of the day to do your further studies. All right. Festus Aqua.
Hello, sir.
Yes. Will you take one? What are the domains of knowledge? All right, James, start it.
Sir, cognitive, psychomotor, and affective.
You come back. You come again.
The domains are 3.
Yes.
And one of them is cognitive domain, which has to do with the mental skills, knowledge, and understanding. Then the second one is affective domain, which has to do with attitudes, emotions, and then values. Then the final one is psychomotor domain, which has to do with physical skills and then manipulation.
All right. Any other view? Any other? James. James Sete.
Just answered the first question.
Right.
Hello, sir.
Yes.
Yeah,
Let's
we have the curricular knowledge. Then we have the pedagogical content knowledge.
Mm-hmm.
Hello, sir.
Yes.
Yeah, we have the content knowledge domain.
Mm-hmm.
And we also have the pedagogical knowledge domain.
All right.
I can remember these two.
Clay, Alex.
Yes, please.
Alex, you want to say something? Let's.
Yeah, what I was saying is that we have the content knowledge domain.
Mm-hmm.
I don't know whether I'm clear. My network is clear. And we also have the pedagogical knowledge domain.
What's the difference between them?
Yeah, the content knowledge domain, that's the mastery of the concept.
Mm-hmm.
That is the theories, the facts, and then the processes that the syllabus contains. While the pedagogical one talks about the understanding of the teaching methods and the strategies that the classroom teacher will use in delivering his or her lessons.
All right. All right. So, yes. Okay. Hand is up. Yes.
Please say your slide is off.
Ruth.
Yes, sir. Good evening.
Good evening.
Sir, please, I want to help with the question too.
Okay.
How to help a student to acquire analytical thinking and problem solving skills. I think that one is by practicing the inquiry-based learning. As a teacher, I think it is necessary to use the inquiry-based learning approach to help students to be able to think critically and then solve problems. And then also a teacher can use case studies so that learners are engaged in the lesson and then they are able to answer questions in the classroom. The same way the teacher can also use questioning and answering procedures in teaching to be able to help learners to be able to think critically and then solve problems. This is my submission. Thank you.
Okay. Any other? All right. What about the forms of evaluation? And then this one, I even made mention of some forms of evaluation in the new curriculum. Forms of evaluation. Hello. How do you evaluate your students? Forms of evaluation do you use?
Please,
Yes.
the forms of evaluation, I think there are so many, but you can use formative, summative, you can even use diagnostic. I'm saying
give specific forms of evaluation. When you're evaluating your student to know whether learning has taken place, what forms of evaluation? How do you go about it?
You can use oral questioning.
Oral questioning, yes.
You can also give them a written exercise.
Yes, assignments, quizzes, what else? Project works and all that. Is that okay? All right. As I said, we'll end here for today. Is that okay? Any questions so far? So next week when we meet, so we'll continue. So use the rest of the day too.
Thank you very much. Well, we need that tonight.
Yes, I'll send it to you. I think the course rep sent me a WhatsApp message, so I'll send it to her and then you post it on the platform. All right. Okay, then.
Hello, sir.
Yes.
Hello, sir.
I'm listening.
Please, concerning the slides, are we going to
Yes.
get everything together so that we print them once, or it's going to be as and when you teach, then you give us the slide?
I
I
think
would
as and
wish
when.
we get everything so that we print. Yeah, at times some lecturers do it that way. That's as and when they
Yes,
teach,
yes,
then
I
they
know.
give the slide.
Yes. I'll give you the for units 1 and 2, then 3 and 4 and 5 and 6. Is that okay? Hello?
Oh, okay.
Yes,
Sir,
yes.
I'm here. Okay.
Pardon?
But sir, please, can't you get all so that we print them once? Then as you come to class, we follow suit.
Yes,
Even
what the
we can
approach
as well read ahead.
yes, the approach I've adopted is what I've told you. 1 and 2,
Okay.
3 and 4. All right. All right.
Okay.
Okay, good night.
Okay.
Good night, doctor.
Thank you.
Thank you so much.